All right, now let's take a look at the standard subtraction algorithm. I wonder if, just like with the addition algorithm, the writing is going to be okay and the narrative is going to be the problem. So let's see what we can do. So we need to subtract 68 from 125. So 125 minus 68. And let's see what happens. Let's model this. So 125, and we need to subtract 68. Now, if we look at this and we look at the subtraction model, or its takeaway, can we take away 60 right now? Can we take away 8? Well, we don't have 6 tens, and we don't have 8 ones. But we can prepare this, regroup this in a different way. So let's actually split up the 10 tens into our rods. Now do we have 60 to take away? Well, yes, we do. So what we did was we rewrote this 125 as 12t and 5, 12t5. So if we're looking at place value, this is hundreds, tens, and ones. So 12t5 instead of 125. Now, can we take away 60? Yes, we can, but can we take away 8? We cannot. So let's rewrite that in a different way as well. So what we actually now have is 11t and 15. So we rewrote 125 as 11t15. All right. Now can we take away 68? We sure can. So take away 68. Let's take away 60. There's our 50 and 60. And let's take away 8. And we took away 8. So what we're left with is 5 tens and 7 ones, 57. All right. So let's look at how we would write this out all in one. So what we did was we realized that we couldn't take 60 from 20. So from 2 tens, 6 tens from 2 tens. So instead we rewrote it as 12, 5 minus 68. Couldn't really do that either because we can't take away 8 singles from 5. So we rewrote that as 11 tens, 15 minus 68. And that we can easily do 57. All right, so let's take a look at how the standard algorithm approaches this. If we were talking about the standard algorithm, we would say subtract 8 from 5. And we would say we cannot subtract 8 from 5. Cannot subtract 8 from 5. Okay, we must borrow. Must borrow a 1. Okay. So theoretically, what we're going to do is we're going to do this when we write. So, cannot subtract 8 from 5. We must borrow a 1. We can subtract 8 from 5. It would give us -3. But that's not what we're doing here. We're subtracting 8 singles from 5 singles. And taking away 8 singles from 5 singles, and the way it is, you're right, we can't clearly take them away. All right, so then we say we must borrow a 1. Well, it's not a 1, it's a 10. And are we really borrowing? Are we going to be giving it back? So there's an issue there. So this whole wording does not make any sense, any connection to what we have already done. All right, but let's keep going. So now we have 15 minus 8. 15 minus 8. Okay, but we borrowed a 1. We borrowed a 1 and a 5. How does a 1 and a 5? How does the 1 and 5 make 15? That's a problem for kids. All right, so 15 minus 8 will give us 7. Now we say 1 minus 6. 1 minus 6. Well, it's not 1, it's 10. And it's not 6, it's 60. And then we say we can't do that, so we must borrow a 1. So we must borrow a 1, but that's not a 1. That's actually 100. Or 10 tens. 10. Oh, where am I? There we go. 10 tens. So we're going to do this, and we're going to borrow our 1. So now we have 11 minus 6 is 5. Okay. So we have a lot of issues here with the narrative again. The writing is not so bad, but we have a lot of issues with the narrative. We are lying to students that we can't take away the larger number from a smaller number. We are lying to students when we say that we're borrowing 1. We're not. We're borrowing a single place value. So it might be a 10, might be 100. We're not really explaining to kids how this 1 and the 5 becomes 15, or how this 1 and a 1 become 11. And we're not connecting the numbers that we're talking about to the place value. We're just looking at digits. So the narrative here is all wrong again. So let's see if we can actually speak through the standard subtraction algorithm using a narrative that might be helpful. And again, we're doing right to left, which is counterintuitive, but we're going to stick with it this time. So 5 ones take away 8. I do not have enough loose ones to take away 8. So I'm going to regroup 110 and split it into single ones. So 15 minus 8 is 7. Now I have 110 minus 6 tens. And again, I don't have enough loose tens to take away 6 tens, so I'm going to regroup the 100 into 11 tens. 11 tens minus 6 tens is 5 tens. My answer is 57. Now notice this kind of verbalization, this kind of narrative connects to what the students know from base 10 blocks, and they can visualize what's happening. It's not just a leap of faith, and it's not magic. So the next activity is a really interesting activity, and it says, well, there's another method that the student used, and I'm going to rewrite this as slightly different. I'm going to rewrite this as in a column, in a standard algorithm kind of way. So what the student is saying is 3 minus 7 is negative 4, and 20 minus 50 is negative 30, and 400 minus 100 is 300. So the answer to this is 266. And the question is that okay? Is that a valid algorithm for subtracting 3-digit numbers? Now let's take a look at what the student is doing. They are actually, Pat is allowing for negative numbers. She does not seem to have a problem with negative numbers. So let's see what would happen if we did it here. 125, let's use Pat's method to solve this, to figure this out. 5 minus 8 is negative 3. 20 minus 60 is negative 40. And then I have 100. So I seem to have 100 minus 40 minus 3. 100 minus 40 is 60, minus 3 is 57. That gave me the right answer. Very interesting. So the question to you is her method legitimate? See if you can figure that out. If you have any questions about it, let me know and we'll go into more depth.